over 10, 15 years, we've seen these systems really grow in size. So when it comes to base isolation in seismic areas, base isolation is really just a way to allow buildings to really move quite a bit. We've seen these systems grow from 10 inches to 30 inches to 6 feet, 12 feet. Even our last project was a 14-foot pan system to accommodate just unbelievable amounts of movement. Wow. And so as we started getting into these larger systems, we started asking ourselves, what other areas of a building need to move? And what needs to accommodate movement so that the building can perform as it needs to, as it's designed, as it's engineered. And one of the areas that we found where that stairs were problematic and they were a challenge to work around because they locked up a building. And so that's really how we get into drift-ready stairs. And you know, it's fascinating. When we heard that stairs were mentioned, we were kind of like, well, how do they need to move, and what can we do about that? And so as every opportunity comes in, we want to try and tackle it, and that's exactly what we did.
Well, I feel like this is a perfect time to get to the stair part of the show.
That it is.
I have been eyeing these stairs. So, Gabe, why don't you do the honors? Hello.
How are you?
I'm wonderful. How are you?
Hello, audience. Thank you for that, Anthony. Anthony mentioned our drift-ready stair systems. So what I want to do is I want to take you and the audience through the story of how did we get here?
Sure.
What have we done and what have we been doing? So Anthony mentioned for the past 50 years of our 70 plus years in existence, we've been dealing with complex building problems. And as he mentioned also, as things begin to advance in the seismic world, we're seeing these joints in the building get immensely large. So as we began to work with our partners in the engineering community, we said to them, what are your pain points? And over stairs continue to come up. And we asked why. What is the problem with stairs? And in most cases, the building has to move. And it's a different type of movement than the expansion and contraction that you normally would think of in an expansion joint system. And that it's a drift movement. So the building actually moves similar to a human spine where it actually displaces itself. The problem with that is in many cases, that design is either deferred or shifted to later on in the project. Because what I want to do now is I want to take the audience and I want you to imagine yourself in your favorite building. Maybe it's your office building that you might not have been at in quite some time. Yeah. And put yourself next to the stairs, and we're going to kind of take you through an evolution of why this is so important from a safety aspect. So when an engineer does an evaluation of the structure, and a moment frame construction, steel construction, it's bolted, welded together, they design that specific movement. So if you can imagine a stair system, that's a giant scissor lock for that building once it finally gets installed.
Yeah.
So that flexible movement that occurs, or that can occur, when you put the stairs back into place, it locks it into place.
Right, yeah.
And it makes a really difficult scenario for that building to survive when it begins to shake and move. So as we begin to apply, how do you solve that issue or the problem, we started to ask the questions of, what do you do when you get a project where you have to deal with that? And what they said is basically, we have to reinvent the wheel at every project. And we have some concepts that we utilize. Things like slotted bolt connections, maybe fixed landing, free bottom. So in the initial phases, we thought, well, this is easy, we can do that. And as we researched it more, we began to go back to our expertise in movement and look at earthquakes around the world. And an example would be the Christchurch earthquake. When we analyzed that and many other earthquakes, we found that the stairs did not perform or survive in these scenarios. So when we compared that to the code and the things that were happening, we noticed that there was this 2.5% interstory drift required in the code. We searched the globe over and found that a lot of the systems that were being utilized on projects today, and even in the past, there was no known mechanism to say, will it actually survive? They were concepts.
Right. Theoretical.
Theoretical. So yeah. I don't want to say we hope they survive, but essentially that's what was happening.
Okay.
So we partnered with the University of Nevada, Reno, and we took some of those concepts to test. The importance of that is we didn't want to try to unravel something that didn't really need to be unraveled. So when we took those concepts of slotted connections, fixed free landing to the next level of the building, we thought, well, if they perform the way that they need to, then the story's kind of over. We can begin to maybe modify something of that nature.
Sure.
What we found in the testing, and we used frequencies for known earthquakes, is that many of those systems didn't even get to 0.7. So many of the systems didn't get to even the normal construction industry standard.
That's incredibly scary.
It is.
Yeah.
So that's where we really dug our heels in and said, okay, we have to solve this problem, because it creates an unsafe environment, and it creates a scenario where you don't really know what's going on under your feet as you're going in and out of a building.
Yeah.
So when we started to build the concepts of the Driftready stair system and the Driftready Connection, we actually then took them to test.
Okay.
And we found that our systems actually exceeded 4% interstory drift.
Oh, wow.
So
Significant.
it is, and actually it was the key to our findings and the key to this entire program. So I want to step back for a moment in time also, and you've heard our other experts speaking of the products that Construction Specialties manufactures and design.
Yeah.
Much of what we do is actually aluminum. So we're metal experts, but much of it's in aluminum. So the other thing we did is we studied the Division 5 miscellaneous metals world, steel fabrication, and we found a really unique fabricator, and CS just recently acquired a company called Platform Manufacturing Group. The uniqueness of them, that group, headed by Jeremy Michaels, is that they had a similar culture to CS. They had an innovative mind, and they actually honed in on the stair portion of the industry. And I want to show you a few things that sort of brings this whole program together.
Okay.
What I have here is I actually have a modular stair system. Okay, so in a normal building, the construction, the way that it happens is the construction starts and the stair tower goes up, and it creates the guiding system for the stairs to get built in.
Right.
Sometimes that can take days.
Okay.
There's lots of coordination. These modular stair systems are just what they define. They're self-supporting, freestanding modular stair systems. So the uniqueness of these systems, and this is how they would fit together on site, and we do what they call fly-in, so these would be craned into place.
Okay.
These systems can be set in hours, not days.
Oh, wow. That's quite a difference. That
It is.
seems pretty revolutionary.
It's very revolutionary. The other unique portion of this is that because they're self-supporting, because they're engineered to support the loads of pedestrian traffic,
Right.
you can use them immediately. So we can set the building heights from floor to floor. We can get your permitting quicker. It's going to save you time and money. The other unique piece of this is that this is an actual connection. So if you can imagine, the corner of this would actually be this connection in real life. And this pin, Angela, is actually an end bed. And thank you.
You're welcome.
So the end bed can be tied back into your structure. So it's super versatile in its ability to, you can leave the structural components in. If you want to embed your landing into the surroundings,
Okay.
at the end of the project, we can actually remove the structural steel supports, and it can be tied into your shaft wall. So the versatility of this system is amazing. The point I'm trying to make is that we've taken these two trades and these two professions and tied them together. So we have not only the expertise in the aluminum manufacturing world, we also now have the expertise in stairs, movement, and steel fabrication.
So you have a one-stop shop. It's a whole team working for them.
That's right.
That's great.
So now for the important part. Do you actually want to see the Driftready Connection?
Yes, I do.
All right, let's check it out.
Okay. Oh, goodness. Here we go. These, it's very sturdy. Feels
Yeah,
very
so
similar.
it's interesting you say that, because one of the largest challenges that we had when we were designing the Driftready Connection is it's the feel of safety. So we know the background of why these systems will be safe, but what we found is that when we went through our original concept, it's extremely difficult to have a stair system that can sit in a static state of mind for most of its life and then have the ability to dynamically move if required.
Right.
So you can see how sturdy they are.
Yeah, it's very sturdy.
So basically, what the Driftready system allows you to do is have a completely solid system within your building that allows appropriate in and out movement. It adds another element to my discussion with you is that EMS services, we also spoke with what happens in the event of an emergency.
Right.
So you're in your favorite building, you're in the lobby, the elevator lobby, and something bad happens, and you run to go down the elevator, and you see this little placard on the wall that says what?
Says take the stairs.
Yeah, in case of emergency, take the stairs.
Yeah.
So if the elevator doesn't work, and your next option is to take the stairs, I think you need to be in a safe environment where you know that based on the test data that we found, that they have not detached from the landing, they weren't damaged in some way that made it unsafe. And as we talk through the community of the EMS services, the engineering community, there is this thing called shelter in place. And shelter in place basically says in an emergency, just stay put, we're gonna come get you. But that adds another complexity to the ability to move in and out of a building, and that is for EMS services to actually get in, to come to you.
Right.
So we had to create a safe scenario where people felt safe using it to get out, and the emergency services felt safe to actually get in.
Right.
So if you want to come up, I'm going to actually show you how this works. Now, I'm thinking right now that the audience is saying, okay, you and I are actually going to go through a massive earthquake right now.
Right.
Things are going to be shaking, falling off the ceiling. And for safety reasons, we are not going to do that. But for the viewers at home, what we're going to do for you right now is we're going to show you a video clip of the testing at Reno. And the interesting piece about that is that we studied earthquakes, and the test that you're going to see, or that you are seeing now, is actually the frequency of the Northridge earthquake.
Okay.
So as I said, when we put Driftready through these scenarios, they exceeded a 4% interstory drift.
Which is incredible.
It is.
So while they're watching this video, what should I personally be, what movement should I be expecting right now?
Okay, so this is going to be a slow motion aspect of watching these stairs disengage from the landing.
Okay, so this is not going to shake that violently, but this violently, but this.
The uniqueness and the magic here is that as Anthony talked about building movement and structural separations, you have to get your mind back to the human spine and how it works. This is not going to create a structural separation at the bottom and the landing of the stairs. What it's actually going to do is almost like a vertebrae. It's going to create an element of movement. So the reason I bring that to your attention is from a safety aspect.
Okay.
When EMS services are coming in,
Right.
or the pedestrians are going out,
Right.
there's nothing you have to step over. There's not a gap. These are designed specifically to disengage with the drift of the building.
Okay.
So that's a super important part of this, and we've created that so that, again, you can feel safe at any time in your building. So as you, the audience, are now sitting in your virtual stairway, think about that when the next time you're in a hotel and you do take the stairs for a bit of exercise versus the elevator. It would be nice if Driftready connections were on those so that you can feel safe in the building that you're occupying at that time.
Right. I mean, I would think if the buildings are designed to move, you want also stairs that are designed to move as well.
100%.